Back in the mid to late 80s, and even stretching into the 90s, my friends and I, we would play Dungeons and Dragons, and we played, of course, on the Commodore 64, and we were pretty much fascinated by the Ultima series of video games. And we also tried, our hand at making video games and designing our own take on maps and different things like that. And so some of the pictures I'm showing here are some of the ideas that we had worked on way back then. And we actually had written some code and had gone fairly far enough where we had almost a functioning game, just not the whole thing. We had it where you could load a map, you could move around a map, and you can do certain commands and things like that. In this video tutorial, I wanted to sort of revisit those ideas, and I thought it would be fun to go back and try to recreate some of that code that we had worked on so long ago. And I'm going to start with, on this video, just creating a game map, a quote-unquote game map, and then trying to do a viewport and display that onto the Commodore 64 and allow you to control it by using the arrow keys to move up, down, left, and right within that game. And sort of inspired by the 8-bit guy who's actually doing a full-on video game called Project X, which he announced on his YouTube channel. But I thought it would be fun to do a quick tutorial and show just how you do some of that stuff, and I'll probably do a couple of follow-up tutorials related to this and build upon it a little bit, but I don't intend to flesh out an entire game. That would take way too much of my time, as I found out when I did the Pack Clone series. But I do think I could have a lot of fun with this, just developing this program a little bit and doing a few tutorials along the way. So I hope you find the time to watch it and enjoy it with me. Before I go too much further, I just wanted to mention that I am using the CBM Program Studio cross compiler, which allows you to write your programs on your personal computer and then compile them and run them in an emulator of your choice. And I choose to use the Vice emulator, and you can download that program over at ajordison.co.uk and click the download tab. So what I have here is the 1.0 version of the basic program that I wrote a couple of years ago, and I used the same program name. Our game was going to be called Zeffeldar, but we never made it for finished making the game. So you can see it's almost been 2 years to the day, a couple of weeks past that. And what I have here is an array of 40 approximately 40 wide by 10 down, and this would be my game map. And I thought it would be easier to write the program in BASIC and then convert it to assembly language, so at least get the logic down in BASIC and then crank it out in assembler after using this as a template. And I have a loop right here reading the keyboard, detecting if you're pressing up, down, left, or right. If you're pressing left or right, then it increases or decreases CX. If you're pressing up or down, it increases or decreases CY. And then it go subs this portion right here. This whole thing is to draw the map. And so every time you press up, down, left, and right, it will go sub down here to draw the map. This is calculating an offset into the map. 1024 is the starting position top left corner of this Commodore 64 screen. Y is defined as 40 characters. Y times dy is how many lines down vertically you want to go. And then dx is how many characters horizontally you want to move across. And that would position you right at the top left corner that you want to display. So if dx is right here, then you would go the box that's generated about 10 characters this way, and then 4 or 5 characters down in a little box. That would be your little viewport. And what it does is a for loop. For j equals 0 to y, y. This is the vertical. And then this for loop is the horizontal. So this for loop draws the characters going across, and then for each, on top of that, this one up here increments, changes the offset for each value to move it down a line to draw the next line. And then it pokes the offset plus I, comma, the ASCII value of the character that's in here. So I know it's a lot to take in, but it's a short little program right here in BASIC. Not a whole lot to it. Let me run it to demonstrate it. And you can see how slow it is, and that's why you need to convert it to an assembly language to speed it up. But every time I push right, it moves the world map or the game map. And then if I push up, it will shift it down a little. And so anyhow, that is the basic program right there that I have written, and I will put this on my newly created GitHub account, which there will be a link in my video in the description. Now, going from this to assembly language, before I get into it, I'm going to demonstrate a little bit about macros and what they are and what they do and how to create a quick little macro, and then I will demonstrate my assembler program that my initial one that I wrote, converting this into assembly, and then the initial one I wrote 2 years ago, and then the one that I rewrote this week to make it more efficient and faster and better and shorter. So what I've done here is I've written a short little program right here for the demonstration, for the purpose of demonstrating a macro. And what it does is it loads the number 1, which is the letter A, stores it in the top left portion of the screen. Then it loads a 2, which I'm going to actually change it to a 1, store it in the color value for the top left portion of the screen. And so if you really wanted to, if you needed to, you could duplicate this code. And say you wanted to do a couple of these. And say you wanted to go 2, 2, 3, 3, but at the same time shifting the positions over. And so you would have here like an A, B, C with a different color. Let's run that. Okay, so let's execute the program. And so you have A, B, C up in the top left corner here. Now you could, using a macro, what it allows you to do a couple of things, but you can reduce this code. So for example, we could do a define macro and end macro, and just call it something like display, character. And then down here you call it display character, and then you pass it the parameters. So the first parameter would be the number 1, the second parameter would be the color or the position on the screen, the third parameter would be the color, and then the fourth position would be this one here, which I need to bring up, the color value position on the screen. Color position on the screen. And then in your macro, you just change these. /1 is your first parameter, /2 is the second parameter, /3 is the third, and then /4 is your fourth parameter. And so just doing that, you've reduced 4 lines of code into 1. Let's run that and see if it still displays the letter A. Okay, so let's execute the program. Boom, ABC. So it still works. So you can see all we have to do here is copy this macro and just adjust the values. This would be letter B, letter C, D, position 400. You can make these whatever you wanted to. The color values, the positions. And so this is just so you get the general idea of what a macro looks like. And so you can take a big long stretch of code, reduce it, and pass parameters down to it. And let's see, we got an error here. Oops, I got a 3, let's make that a 4, okay. Execute the program. And we have A, B, C, D. That's cool, right? So let's, I mean, you could keep it going if you wanted to. Now, it's important to understand that, you know, doing this, even though it reduces it, makes it more readable on the screen, it does expand it on the computer. So let's take a look at that. When you press F5 to run the program and to compile, let's see what's actually happening. You see here, this would be one macro expanded. This is the second macro, third macro, fourth macro, fifth, and sixth. Okay, so that's what I use macros for. It also is an easy way to pass parameters down, but it reduces the program size, but on this viewable on your source code, but then on the back end it has to expand that out. So keep that in mind when you use a macro. Now, the program that I wanted to quickly look at, I'm going to run this. It was my first attempt a couple of years ago. I wrote this. You could see 4/11/2015, almost 2 years to the date. And you can see what it does here. I have a little map that I wrote, and then I can use the arrow keys, or the keys that I defined for arrow keys, the same ones in GPAC. A for left, S for right, W for up, and Z for down. So this was my first cut at converting that basic program into assembly language. This is the array, the string. In my first attempt here, I shortened it a little bit. And the reason why I was describing right here in the earlier segment what macros do is because I do utilize a few macros to make the program code look a little shorter and to make it easier to understand, or to try to make it easier to understand. Sometimes it backfires and gets more complicated when you use macros. So these are my macro definitions, and then the part of the program where it reads the keyboard, up, down, left, and right, is right here. So if you move left, then it goes down to the left portion where it decreases X. If you move right, you increase X. If you move up, if you move down, you increase or decrease CY. And then the routine where it does the 2 loops is right here. And the beginning of the vertical loop and then the beginning of the horizontal loop is right here. So this is the entire program. And in this version of the program, I'm using the 0 pointers, FB and FC, which I don't like using those 0-page pointers. So I stripped those out in my optimized version of this program, which I'm going to demonstrate right now. So rather than this, which was a good first attempt, I took that and then I created this program, which I built upon the prior one. So I expanded this out to 40 and down 10. I still have a few macros, but fewer of them. And then I still have the part where you're moving up, down, left, and right, and you're grabbing the keyboard from the a keystroke from the keyboard. And then in the movement routine, now this is the entire routine where it has the vertical loop and then the horizontal loop right here. So this is the horizontal loop that draws the characters going across. And then the loop above that is which grabs the next line and then draws the next line, pushes it down, draws the next line, pushes it down, draws the next line. And I just have a few little macros here. And let me run this one instead of blabbering. Now, I put in a delay down at the bottom, and so this is adjustable because the program was running so fast initially. I had to delay it, so let me speed it up a little. So you can see I can move all around. It wraps around if I go all the way to the right. If you go all the way down, it wraps around, or all the way up. And if I wanted it to go even faster, and then if we took the delay out entirely, you can't see what, that's why I have the delay. You can't even see where you're moving. Now, obviously, so I'm gonna put the delay back in. This program is at the bare bones level right here, and there's no color in there, and there's not a whole lot else going on. But it took me a little while to rewrite this, and I'm actually proud of the output or the outcome. And so it's a lot more cleaner looking, and it's a lot more efficient than the original version. Now, one of the things I wanted to point out was that in the basic program, it's nice and short and succinct, but it's calculating this offset up here by doing a multiplication, and anyhow, it's not very quick. It's not a very efficient and fast way of doing it. And so in order to get around that, on the program here, rather than multiplying and calculating the positions, what I have here is a set of constants. And this is literally the top left portion is the low byte and the high byte. So 0400 is the top left portion of the screen. 0428 is down 40 characters. It's the next line, one beneath it. The third line, the fourth line below, fifth line, all the way down, defining all the positions on the screen that I'm going to could possibly use. Then I did a similar thing with the game map. I located the map at position 2000, or in memory location 2000, and for each line I just had it 00, so 2000 is line 1, 2028 is line 2, 2050 is line 3, 2078 is line 4, all the way down to this bottom one, which is 2168. So if you had to increase the width of the map, then these constants would have to get updated. And it's a method of doing a lookup rather than doing a multiplication or several additions in order to get to the same result. And then same thing here. So anyhow, I just wanted to cover that really quick, and that's what the Y value is loading when you go down a character. Every time you increment Y, this sub right here, or this macro store values, is just loading from comma Y, loading the high and the low bytes. And that's how it positions itself in the map. Anyhow, I know it's kind of complicated, but that's how I was able to make the program run a lot faster. Now, in a future video, I'm going to show how to take the game map that we have here, and if you imagine like these minus signs that are going across as being water, I'm going to show how to animate those using redefining the character set and using a program interrupt. And there will be other videos related to this theme. So stay tuned, and if you have an idea for a topic that you would like me to cover in a tutorial related to this project, drop me a comment or send an email to graydefender@outlook.com. Thanks for watching.